In today's video, I'm going to introduce you to Newton's three laws of motion. Newton's first law. By definition, it means an object at rest always stays at rest, and an object in motion stays in motion with a same speed, or constant speed, and in the same direction, unless acted upon by an unbalanced force. And I underlined, unless acted upon by an unbalanced force. And that means that if we have an unbalanced force, and we'll talk about this later, we are going to accelerate. Okay, we're going to have an acceleration. So essentially, all the first law says is you either stay at rest, or you'll be moving with a constant velocity, unless an unbalanced force acts upon you, which in turn makes you accelerate. So here's a little flow chart to kind of help you out to see if Newton's first law applies. Forces are balanced. So that means either the object is at rest, okay, or the object is in motion. Now, at rest means velocity of 0. If you're in motion, your velocity is not 0, and it can be anything but 0. Our accelerations are still 0 because we're not accelerating. Now, if the forces are balanced and the object's at rest, it will stay at rest. If the object's in motion, it will stay in motion with the same velocity, same speed, same direction. A term that comes up, this is also known as the law of inertia, is what is inertia? Now, inertia, if you recall from the Bill Nye intro, is the resistance of an object has to its change in motion. So what that means is if an object's moving with a constant velocity, right, then how much inertia it has is how much it will take to change its velocity or to change its state of motion. So inertia's resistance it has to the state of motion. Now, how this was studied is that let's take a look at an object, right? And we have it rolling down a slope, and it comes back up. If there was no friction, okay, then if we let go, it will roll down and come up to the same height. If we take another object and we change the shape of our bowl that we're rolling the ball in, if we release it, it will go here and roll up to here. But at the end of the day, initial height equals final height, okay? And that's what the first law is telling us, is this will happen if there's no other force, okay? But obviously there is, and we'll talk about that later. I mean, there's friction and other things that could change this. But if there was no friction, first law says these things would be true. If friction could be eliminated, if we rolled it and the object ended up on flat ground, it would continue to roll at this constant velocity forever, okay? And again, as if friction were absent, or wall or something to stop the ball. But if the ball got down, once it got to the flat surface, its velocity would stay constant. And it would roll forever until an unbalanced force acted upon it, either the wall or friction or something like that. Things to consider, and these are two important facts. Fact 1, forces don't keep objects moving, okay? Forces can slow things down. Forces can stop objects. All right? And also, when we talk about inertia, it's also is talking about mass. Now think about this. Inertia is resistance to change. If you have a pebble and you have a boulder, if they're rolling at the same velocity, which one would be easier to stop? Well, the boulder, right? Its resistance to change would be a lot less. And that's because its mass is a lot less. It has a small mass as opposed to a big mass. The boulder, on the other hand, would require a lot of force to get it to stop its motion or to change its motion. In fact, if it's a big enough boulder, it'd probably roll you over if you tried to get in front of it. So therefore, mass and inertia go hand in hand when we discuss them. So, inertia and motion. Inertia, the tendency of an object to resist changes in its velocity, which means it's also the tendency of an object to resist acceleration. So if an object will not accelerate, okay, either speed up or slow down, it's because it has a lot of inertia, all right, which also means it has a lot of mass. So bigger objects are harder to change their direction or velocity. Now, balanced forces mean no acceleration. So, for example, a book sitting on a table. You have gravity pulling the book downward, but the book is not going downward because the table's pushing back up. When we see this, the force of the table being pushed back up on the book and the book being pulled down by gravity are equal because the book is not accelerating, it is standing still. Same thing if you're standing on the ground, okay? Gravity's pulling you down, but the ground is pushing you up, or the floor is pushing you up. And therefore, you're going to have the forces are balanced if you're not accelerating, which if you're standing on the ground, you're not accelerating up or down. You're standing still. Unbalanced forces mean acceleration. So if we look at the book, if the forces are not balanced, so first off, we have gravity pulling down and the table pushing up. These are balanced, okay? So the object is not accelerating here in the vertical or in the y, right? But in the x, we have friction pushing backwards, okay? So the book is moving to the right, but friction's going to the left. That means the object's going to slow down, which means it's going to accelerate. It's going to be a negative acceleration. So when there's a force that are unbalanced, in this case friction, then the book is slowing down because it accelerates with unbalanced forces. So that's Newton's first law. Newton's second law is a little easier to understand, okay? And I got it in words here. This is the textbook definition, is that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass. Here's what that means. The force on an object, the net force, so add up all the forces. The net force on an object is equal to its mass times its acceleration. So second law is more of a math problem. F equals ma. Net force equals mass times acceleration. Newton's third law. For every action, there is an equal and opposite reaction. Okay? Now, when we talk about the third law, we always got to think about forces acting on an object. They come in pairs, and we call them action-reaction pairs. And identifying those is probably what's difficult, but really all you got to do is who is pushing on whom and in what direction. And if you can talk about those two objects that way, you know which way they're going. So for example, the ball is hitting the catcher's glove, right? The ball is applying a force onto the glove. But Newton's third law says equal and opposite. The glove is applying a force equal to that back on the ball. A balloon, get air pressure pushing out onto the balloon. The balloon is pushing back on the air particles with equal but opposite force. So the balloon in the air is our force reaction pair. Ball and glove, force reaction pair. That is all.